Okay, welcome back, everyone. Hope you had a good week. Today, we're going to look at the 2020 Gauss math contest. Now, you're wondering, like, why? Why do I have access to this right now? It's because, well, the Gauss contest was actually supposed to be hosted this week. If you don't know what the Gauss contest is, it's a contest hosted by the University of Waterloo. It's multiple choice, and it has 25 questions. And it's an increasing difficulty with parts A, with easy, and part B with like normal difficulty, and then part C has like the really challenging problems. And each of them are worth different amount of points. And so the 2020 Gauss Math Contest was supposed to be held like this Wednesday or this Thursday, so like 2 or 3 days ago. But of course it was canceled because of the coronavirus. But they did post their contest on their official website. But they didn't have the solutions or the results. They just posted the contest, so anyone could just look at the problems and try to solve them. And yeah, and so today we're going to try to solve this 2020 Gauss math contest problems. All of them, hopefully. We might have to skip some of them just for time's sake, but let's try to look at all of them. And these are also from easy difficulty to challenging difficulty. So let's get started. Question 1. How many numbers in this list are something's blocked? Okay, are less than 1. Sorry, my Zoom app was blocking one of the words. Okay, so this should be a simple problem. If you can just type the answer in the chat or something, that'll be great. How many of these numbers are less than 1? Okay, 3, perfect, right? 0.03, that's less. 1.5, that's over that, so it doesn't count. We have negative 0.2, that counts, and 0.76 also counts, so we're good. Oh yeah, you can also type the letter too. So D, so the answer is D, which is 3. Perfect. Question 2. The total cost of 4 1-liter cartons of milk is $4.88. What's the cost of 1 liter carton of milk? Just type the answer. Oh, someone's in the waiting room, sorry. Okay, someone just type the answer in the chat. It should be fairly simple. So the first 10 questions of the Gauss contest are part A. So they're all easy difficulty. E, perfect. 1.22, that's good, right? So 4 liters cost 4.88. To get the cost of 1 liter, you just divide by 4, and you get $1.22, which is answer E. Perfect. Okay. Question 3. Which of the following is equal to a whole number? Type the answer in your chat. So you can type the number itself, or you just type the letter that it corresponds to. E, perfect. E, so 12 divided by 2. 12 divided by 2 is obviously 6, and so we're good. So let's continue. Question 4. If x is equal to 4, okay, I am muted. There you go. Okay, can you guys see the slideshow now?
Yes.
I hear one yes. Okay, that's good enough. Okay, so you guys see the question? Let's look at it. If x is equal to 4 and x plus y equals 0, what's the value of y? Simple algebra. So just type your answer in the chat. -4, perfect. Everyone says -4, good. So what? If you have x equals 4, you can have 4 plus y is equal to 0. That means if you do the algebra, y should equal -4. Perfect. Okay. Question 5. A line segment is drawn joining the points 0, 6. So you see there's this diagram right here to show you the line. Here's 0, 6 and 4, 0. So this point right here. And what's the area of the shaded triangle? Type the answer in the chat if you know the answer. 12. Good. Yep, it's 12. So remember, area of triangle, base times height. The base here we can treat as 4 or 6. Let's just treat it as 4. Base is 4, and the height is 6. And this is a right angle triangle too, so that's perfect. So we can treat the base as one leg and the height as the other leg. So 4 times 6, that's 24, but we also divide by 2 because that's area of triangle formula. And so 24 divided by 2 is 12. Perfect. Okay, question 6. A perfect square is a whole number whose square root is also a whole number. You guys should know that already. For example, 144 is perfect square since square root is 12. How many perfect squares are between 2 and 20? Type your answer in the chat once you know. There should be more than 2. It's 3. Okay, it's 3. Okay, I'll count them out. So there's 4. The square root of 4 is 2. There's also 9. The square root of 9 is 3. And then there's 16. 16 is a square root. Sorry, the square root of 16 is 4. So, and then if we keep increasing, it'll go over 20. So we have all 3 of the perfect squares between 2 and 20, and there's 3 of them. So answer is D. Okay. Question 7. Yvonne has 4 different notebooks and 5 different pens. He must bring exactly 1 notebook and exactly 1 pen to his class. Sorry, disconnected once again. I hate my Wi-Fi. Okay, let me share the slideshow with you again. Okay, here's the question. Hopefully you guys remembered it. Type your answer in the chat once you know it. This is just simple combinatorics, right? Does anyone have an answer? C, 20, perfect. Yeah, so to find number combinations, you can just multiply number of notebooks by the number of pens. So each notebook each of the 4 notebooks can correspond to each of the 5 pens. So then you just do 4 times 5. And that gives you 20. Simple combinatorics, right? Let's continue. Okay. In the pie chart shown, 168 students chose bananas as their favorite fruit. How many students chose apples as their favorite fruit? They'll give you some. Okay. We have an answer. It's 42. Shouldn't be 42. Yeah, it should be 56. Right, so, okay. So let's look at the pie chart in terms of like fractions, okay? So if we consider like the whole thing. Apples, this makes like a quarter of like total number of fruits. Bananas, they make up 3/4 of all the fruits. And so when you compare their fractions, 3/4 is 3 times larger than 1/4, right? And so all you have to do is divide 168. So that's number of students who chose bananas. So you divide that by 3 to get a quarter. From 3/4 to a quarter, you divide by 3. You do the same thing with 168, and that divided by 3 should give you 56. Yeah, 56. Okay. Let's continue. A bag contains letters as shown. Alina randomly chooses one of the letters from the bag. What is the probability that Alina chooses a B? Simple probability question. You just count. That's all you have to do. What do we have? So I was saying a quarter. Let's see. Okay. So B, there's 2 possibilities. So that's the numerator. We have 2, and total number of letters in the bag is 8. 2 out of 8 is 1/4. Perfect, guys. Doing well. Question 10. Vita picks a number from 1 to 10. Belil adds 5 to this number and calls his result B. Callie subtracts 5 from Vita's number and calls her result C. What's the value of B minus C? Okay. This might be a little bit tricky, but you can just pick a random number from 1 to 10 and just try it out. It's not 5. Think carefully. Yes, it is 10. It is 10. Why is it 10? Okay. Let's do it in an algebra way, actually. It doesn't really matter like what number you choose. It doesn't have to be between 1 and 10. It can be anything. Let's call it x. Okay. So one of the other people, they added 5 to this number. So then the new number will be x plus 5. And then another person subtracted 5 from x. So that means we have x minus 5. Yes. Okay, so they're all adding into each number. Good. Okay. So we have one number is x plus 5, and the other number is x minus 5. Now we subtract them, find the difference. Just brackets around this one. So if we get rid of the brackets, we have minus x. This minus becomes positive. We have plus 5. And now let's simplify this. We get rid of the x's, because x minus x is just 0. Now we're left with 5 plus 5, and that's equal to 10. And 10 is our answer. So let's go back to slideshow. 10 should be, yeah, answer E. Okay, give me a thumbs up if you understand that. Good. Good, once you know how to do algebra, this is pretty easy. Yeah. Okay. Question 11. Each Tuesday, a bus makes its first stop at Gauss Public Library at 1 p.m. It continues to stop at the library every 20 minutes. Its last stop is at 6 p.m. What's the total number of times that the bus stops at the library on a Tuesday? So like guys, think about this and type in the answer once you know it. It shouldn't be E, no. 15 is not an answer. Okay. I believe the answer is 16. Someone got it. It's 16. Here. Let's solve it. So let's look at how many 20-minute intervals there are between 6 p.m. and 1 p.m. Oops, let's clear that. Okay, so between 1 p.m. and 6 p.m., that's 5 hours in total. Okay, we can use 6 minus 1. That's just 5 hours. Now, how many 20-minute intervals are in 5 hours? Well, there are 300 minutes. So 60 times 5, that's 300 minutes in 5 hours. So now we divide that by 20. and that should give us 15. But 15 is not our final answer. That's not the number of, like total number of 20-minute intervals there are. Can you see why? It's because, so we're including because we have to include 1 p.m. and 6 p.m. Actually, we have to include we have to add 1 to 15. Because, so if we only have 15 intervals, that means we've only included either the 1 p.m. or the 6 p.m. mark. And so that means we have to, when we have to include both of them, we'll just have to add 1 to 15. So that gives us 16. So give me a thumbs up if you understand that. Sounds good? Okay. Let's continue. In the addition shown, each of P, Q, and R is a digit. What's the value of P plus Q plus R? Type the answer once you know it. Yeah, don't forget to know how to add 2 numbers on top and to bottom. Remember, you have to carry once if it's greater than 10, right? What is P plus Q plus R? You're gonna have to find each of them. You're gonna have to find what P is, what Q is, what R is. So first find R, right? Remember, when you're adding 2 numbers from top to bottom, you go from right to left. 20. That sounds about right. Let me see. I think 28 is the right answer. Yeah. Here, I'll show you guys. Why is it 20? So let me see if I can mimic it on here. P, Q, R. Let me add space in between them. We have 1012 as our answer. Yeah. So this 2 corresponds to the R plus R. Okay. So that means R could either be 1, but R could also be 6, because 6 plus 6 is 12. And you keep the 2, but you have to move the 1 to, the number to the left, right? But it has to be 6, because you have a 1 right here. You have there's a digit of 1 right to the left of 2. And you have these 2 Q's. If you try to solve for 2Q is equal to 1 or something, you'll get a decimal number. So you can't have R equal 1. You have to carry a 1. So you have solve for 2Q plus 1 is equal to 1 or 11. And then Q will be a whole number. So now we know that R is 6. 6 plus 6 is 12. And we had to carry the 1 right here. And now, so that means Q plus Q, so 2Q would have to end in a 0. So that means Q could be 0 or Q could be 10. But Q could be 5. Q is 5 in this case. Because, okay, so it is P. So P would have to equal 10. Well, 10 is 2 digits, and P has to be 1 digit, right? So Q cannot be 0. So Q has to be 5 to carry that 1 to P. And so P would equal 9 in this case. And now we have the values of P, Q, and R. So now we have 9 plus 5 plus 6, and that gives us 20. Okay, give me a thumbs up if you understand. Sounds good. Let's go. Okay, question 13. Emil and Olivia ran a race. Their race times totaled 1 hour 52 minutes. If Emil's time was 4 minutes less than Olivia's time, how many minutes did it take for Olivia to run the race? Also some simple algebra. So I'll let you guys figure that out. So convert 1 hour 52 minutes to minutes, right? And then do some algebra. You know, it might be hard to do this in your head, so let's try it on a whiteboard. Let's see whose time is less. Emil's time is 4 minutes less. Got it. 58, okay. Let's see. So this is just a simple algebra equation, right? Let's let O be Olivia's time. That's what we're trying to solve for. When you add them together, you get 1 hour 52 minutes. If you convert that to minutes only, you get 60 plus 52, which is 112 minutes. Okay, 112. Now what is Emil's time? How do you express Emil's time with the O variable? Well, we know that it's 4 minutes less, so that means we have to subtract 4 from O. And now we can solve this. If we expand the brackets, get 2O minus 4 equals 112. 2O is equal to 116. And now we just divide 2 from both sides. We get O is equal to 58. Hopefully that is the right answer. Yep, that's an answer. Okay. Okay, O is equal to 58. Good. Give me a thumbs up if you understand. Perfect. Okay. Let's continue. Rectangle ABCD has side length AB equals 16 meters and diagonal length AC equals 34 meters. As shown, the perimeter of rectangle ABCD is what? So let you guys figure it out. Use Pythagorean theorem. Right. Actually, it's a bit difficult to do this without a calculator, right? So 4 squared, it's probably a pretty big number. Okay. Let me figure it out. I'm gonna cheat, use a calculator. Oh yeah, by the way, you can use the calculator on the Gauss contest. So that's good. Okay. $92. Good, it is 92. Good job. But why is it 92? Let's look. Okay, let's get rid of this. So if we do Pythagorean theorem, we have a squared is plus b squared is equals c squared, right? Let's say we're trying to solve for a. A would be the longer side of the rectangle. B, we have 16 squared equal to 34 squared. A squared is equal to 34 squared minus 16 squared. You should get a squared is equal to 900, hopefully. So if a squared is equal to 900, that means you take square root of that. A is equal to 30. Here, let me double check. Good, yeah. So we have A is equal to 30. So the longer side of the rectangle will be 30 meters. And now you can find the perimeter. You just take, you can just add all the sides, or you can do it bit simplify. You just multiply 2 by the sum of the 2 of the sides. So you can do 2 plus times 16 plus 30. Because the 16 and the 30 are repeated on the other side, right? So we had 16 and 30, and 16 and 30 as well. We can just multiply 16 plus 30 by 2. So that's 2 times 46. And that gives us 92. Right? Give me a thumbs up if you understand. Good. Okay. It's fairly simple and straightforward. Question 15. Francesca chooses an integer from the list -4, -3, blah, 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 all the way to 6. And then a second integer that is larger than the first. How many such pairs of integers can she choose so that the sum of the pair is 3? Well, you guys figure it out. And type your answer in the chat when you have one. Yeah, I think it's 5 as well. Okay. Let's actually do it over here, okay? Yeah, a lot of people say 5. Good. Okay. Let's look. Okay, so let's choose let's start at -4. So let's say like -4 is one of the numbers in the pair. And now we have to choose a bigger number such that the sum is 6. So -4 plus the second number, sorry, equals 3. So -4 plus the second number equals 3. However, you can see how we can't do that because, well, the largest number in the set that's bigger than -4 is 6. Okay, and if we add -4 and 6, you get 2. So -4 cannot be a number in any of the pairs. Okay. Now let's go to -3. -3 can go with 6 because -3 plus 6 is equal to 3. So that's one pair. Okay. We can do the same with -2. -2 pairs with 5 to get 3. So that's 2 pairs. -1 pairs with 4. So -1 plus 4 is 3 as well. So that's a third pair. And we have 0. 0 plus 3 is 3. So that's our fourth pair. And finally, we have 1 and 2. 1 plus 2 is 3. And that's our fifth pair. And that's how we get 5. And that's answer B. But give me a thumbs up if you understand. And yeah, we can't reverse the order of the numbers inside the pair because the second has to be larger than the first. So we can only have 5, not 10. 10 isn't even an answer, but okay. Let's continue. In this diagram, triangle QRS is isosceles and right angled. And it has properties that QR is equal to SR. I wonder why they have to tell you that, but okay. It's in the diagram anyways. Okay, QR is equal to SR and angle QRS is 90 degrees. Line segment PT intersects SQ at point U and line segment SR at point V. If angle PUQ is equal to angle RVT, which is equal to a variable called Y, so you see them right here, what is the value of Y? So you guys figure that out. Ooh, okay. Okay, you know, let's do this together. So let's draw this out. I have to draw a triangle manually. That's trash. All right, here we have our triangle. And we have the line that intersects right here. Let's just look at that. Okay. And we have angles of Y over here. Whoops. Didn't mean to look at those emails. Huh. I guess didn't copy paste correctly. Y over here. And we have y over here as well. Okay. Oh yeah, and we also have this 90-degree angle right here. All right. Remember, since this triangle is isosceles, that means we also have two angles that are equal to each other. And there are these two angles right here. So here and here. And they should be equal to 45 degrees each. Okay. Well, let's look at the bottom left one. That's more important. So this one is 45 degrees. Let me put it outside the triangle. 45 degrees is this angle right here. If you notice, if you see the opposite angles, that means this angle here is y. We have this small triangle right here. And inside triangle, we have 45-degree angle. This angle is equal to y because it's opposite to this angle. This angle is also equal to y because it's opposite to this angle right here. So now we have an equation of y plus y. So angles of a triangle add up to 180. So that means y plus 45 is equal to 180 degrees. 2y is equal to, so 180 subtract 45, 135. And y is a decimal. Y is equal to, let's see, 67.5, hopefully. Y should be equal to 67.5. So give me a thumbs up if you understand that. Yeah, just to review, just like it was a bit confusing. Sorry about that. So what we did was we solved for this angle right here because this triangle here was isosceles and right angled. We had a 90-degree angle right here. Since this angle has to be equal to this angle has to equal 45 degrees. And we used the opposite, and we had to use opposite angles to figure out that this angle right here inside the small triangle is y, and this angle is also y. And when we make an algebraic equation to solve for y, we get y equals 67.5. There you go. And yeah, that's answer C. That's perfect. Okay, let's look at question 17. The point totals that Mark scored in 5 basketball games were X, 11, 13, Y, and 12. How many different possible medians are there for his 5 point totals? Once you know the answer, just type it in the chat. And remember, X and Y have to be integers, right? Because number of points in basketball game. Obviously, they're integers. Here, let's look at it together. Okay, if you guys don't know what a median is, it's basically the middle number in a sequence of numbers where the numbers are in increasing order. So let's say we have X, Y, 11, 12, 13. Say we have that. The median here would be 11. Let's assume that X is smaller than these numbers and Y is also smaller than these numbers and bigger than X. This means that 11 would have to be the median. And you can put X and Y in different spots, right? Put X right here, like between 11 and 12, you could put X between 12 and 13, you could put it after. Same thing for Y. But you're limited to like what kind of medians you can have, because these numbers will probably have to always stay together. What I mean by that is like 12 will always come after 11. Like 12 will always come right after 11 unless X and Y is equal to 11. And 13 will always come right after 12, even if unless X or Y is equal to 12, and they will have a position right here. But that means our 3 medians have to be these numbers right here, right? No matter where you place them. So say we have to place X and Y on the two edges. So first example, we had our median is 11, so you had to put x and y over here. That means our median here is 13. So that's an example of how median can be 13. How can be 12? We can make x equal to 11, and let's put y after 12. So let's put it right here. Why not? And that's how we can get a median of 12. And so there are only 3 possibilities for our medians. Give me a thumbs up if you understand. It was a bit difficult to explain this, but you guys can probably see it. Why you can only have 11, 12, 13 as your median. Okay, let's move on. Question 18. 3 different views of the same cube are shown. What's the symbol on the opposite face of the dot? So I'll let you guys figure that out. And once you have the answer, just type it in. Yeah, just type out the letter for this one. So type A, B, C, D, or E. Which one do you think it is? It's not the black square. It is C. It's the square of the x. Let me see how to explain this, but okay. Let's look at this cube and then this cube. You see that they both have the empty square on the top. And so that means, let's see what else. White dot, okay, that's okay. Now, so look, so trying to find the opposite face of this dot right here, the black dot right here. Yeah, sorry about, I should have made this black, but hopefully you guys can see, like the filled, let's call it like the filled circle, the filled dot. So this dot right here, that's what I'm referring to. You see how both of these cubes have the top right here, the empty square at the top. And so if you look around like this, you'll get these 4 sides right here. So you have this x, the square of x, you have an empty circle, and you have the dot and then the plus sign. So it means, what I mean by that is like when you rotate this cube, like I know horizontally, you will see these 4 faces. Give me a thumbs up if you understand that. Hopefully, yeah, it's a bit hard to explain this problem. Yeah, so if you flip it, you see these 4 sides. And then if you want to find the opposite side of this dot, that means the dot has to be over here. So if you rotate this cube more horizontally, that means the dot has to be right opposite to this x, and then the plus sign will be opposite the empty circle. And so that means this dot is opposite to the x, so that means our answer is C. Give me a thumbs up if you understand that. And if you're still unsure, you can, like, I don't know, try to draw your own cube, make your own cube at home or something. So get a piece of paper and fold it and draw the symbols on top of them and see what you get. Yeah, wonder why this is a math question, but let's continue anyways. Question 19. X is 20% of 50. 40 is 20% of Y. 40 is Z% of 50. What is X plus Y plus Z? Give you guys some time to figure that out. It's just simple algebra as well. Here. Let's just do it together. Let me memorize these. Yeah, probably can't, but whatever. Okay. So we have x is 20% of 50. 20% as a fraction, it should be 1/5. So x is 1/5 of 50. So if you do 1/5 of 50, you can just multiply 50 by 1/5. And once you do that, you should get 10. So x is equal to 10. What was our next one? 40 is 20% of y. 40 is 20% of y. 20% as a fraction is, well, we did that, it's 1/5. So 40 is 1/5 of some number y. So to get y, we would have to multiply 40 by the reciprocal of 1/5, which is 5. So now you have 40 times 5 equals 200. So if you look at 200 and look at 40%, 40% looks like that it's 20% of 200. So it's perfect. Okay, so that's y. Y is 200. Now we have 40 is z% of 50. This might be a little bit tricky, but let's make 40 over 50 a fraction. If we simplify that, we get 4/5. 4/5, if we actually divide the two numbers, we get 0.8. If you make that into a percentage, you just multiply it by 100. So we get 80%. And so that means z is equal to 80. Now we can just add. Now we can take the sum of x, y, and z. So x plus y plus z, 10 plus 200 plus 80. And that should give us 290. And let's double check if that's an answer. Okay, it is. So 290 is our answer. Give me a thumbs up if you understand. Very good. I see. Okay. Let's look at question 20. If a and b are positive integers, and 20/19 is equal to 1 plus 1 divided by, in brackets, so this is the denominator of this fraction. This whole thing inside brackets is a denominator. So we have 1 plus a over b. What is the least possible value of a plus b? Let's try to solve it algebraically. Let me draw it out actually, so it'll look more clear to you guys what it actually looks like when you when it's not typed out. Okay, so this is what the equation is supposed to look like on the contest. When I had to type it out, I had to put everything like in the same line. So it kind of looked a bit difficult to like, to see where it goes where, but this is what it looks like. We have this 1 plus a over b in the denominator of this fraction, and we have this in this part as well. So let's try to solve this algebraically. So let's move this 1 to the left side. So let's subtract both sides by 1. So 20/19 minus 1, that should give us 1/19 equals, so 1/19 would equal this fraction right here. 1/1 plus a divided by b. Hopefully that's clear to you guys. And now we can take the the reciprocal of both fractions and set them equal to each other. So let's do that. So now we have 19 is equal to 1 plus a over b. Okay. So now we have this. And so now a over b, now we can subtract both sides by 1 again. So let's do that. So 19 subtract 1, that's 18, equals a divided by b. So we want a and b to be as small as possible, right? So that means let's let b equal 1 then. And A and B they have to be integers. Yeah, A and B have to be positive integers. So B has to equal 1. That's our smallest positive integer. Then that means A is equal to 18. A is equal to 18. And so what was it asking for? What is the least possible value of A plus B? Okay, so we have to add these up. 18 plus 1. And that gives us this final answer of 19. Give me a thumbs up if you understand. Sounds good. Looks good. Okay. You know what? I'm going to skip this problem and go into the more interesting problems. So I think we're a bit out. We have less than 15 minutes left. Yeah, we can get back to it if we have time, but it should be fairly simple. Let's look at this one. 3 spinners are shown. The spinners are used to determine the hundreds, tens, and ones digits of a 3-digit number. So here we have the first digit, the hundreds is the first digit, the tens is the second digit, and the ones is the third digit. But how many possible 3-digit numbers can be formed such that they're divisible by 6? So remember your divisibility rule of 6. It has to be divisible by 2 and 3. Just remember that. So if you have the answer, type it in the chat. You can probably you can count all of them. And you're quite limited to the possibilities you can get. So remember, the number has to be divisible by 6, which means it has to be divisible by 2. And when it's divisible by 2, the number has to end in 2, 4, 6, 8, or 0, right? It has to be an even number. So that means the ones digit cannot be 1 or 3. We only choose between 0 or 2. I think there's more than 9. Here, let's look at it. Okay. So let's say our ones digit was 0. Okay. Now let's choose the hundreds digit. Let's let the hundreds digit be 1. Now, if we want to determine the tens digit, we have to look at the divisibility rule of 3, which is that the sum of the digits has to be a number that's divisible by 3, right? So if we look at 1, and we have 0, we have 1 plus 0, that's 1. So now we have to add another number to 1 to make it divisible by 3. And now let's look at the tens digits. We have 5, 1 plus 5 is 6, that's divisible by 3. We can also have 8. 1 plus 8 is 9, so that's 2 of them so far. There's obviously more. So that's 5 and 8, good. Okay, now let's look at 2. 2 has only one option from the tens. We have to do 2 plus 7 to give us 9. If we add with these other ones, it won't give us any numbers are divisible by 3. You can try them out. But 2 has only one possibility. Okay, so we had 1 for 2, hundreds for 1, we have 2 possibilities. If 100 is 2, we have 1 possibility. Let's look at 3. 3 can obviously only add up with 6. These other ones won't work. 3 plus 6 is 9. That's divisible by 3. So that's 1 possibility for 3. Now for 4, we have possibilities of 5 and 8. And so 4 plus 5 is 9. 4 plus 8 is 12. They're all divisible by 3. So we have 2 possibilities for 1, 1 possibility for 2 and 3, and we have 2 possibilities for 4. So if you add them up, 2 plus 2 plus 1 plus 1. That should give you 6. That's not our final answer. That's the number of possibilities when the ones digit is 0. Now let's look at the other possibility where ones digit can be 2, right? It has to be an even number. Now if it's 2, let's choose 1 for hundreds. So now we have 1 plus 2, that's 3. And the only number for the tens that we can choose to go with 3 has to be 6. So it's 1 possibility for 1. Now let's look at 2. 2 plus 2 is 4. Now 4 can go with 2 of the tens digits. We could go with 5. 4 plus 5 is 9. You can also go with 8. Oops, sorry about that. Those are next questions. And we have 4 plus 8 is 12. So 2 has 2 possibilities. Now we look at 3. 3 plus 2 is 5. 5 can only go with 7, which is 5 plus 7 is 12. And finally, we can look at 4. 4 plus 2 is 6. 6 can only go with 6. And so it's 1 possibility for 4. So if 1 plus 2 plus 1 plus 1, that should be 5. And those are all the possibilities we have. We have 5 plus 6. So that gives us a total of 11 possibilities. Give me a thumbs up if you understand. Okay, sounds good. Continue. I will skip this one too. Let's look at here. Let me see which problem we should do. I think we only have time for one of these. I'm gonna look at question 25. It's a pretty amusing problem. Let's look at question 25. A sequence of positive integers with 2020 terms is called an FT sequence if each term after the second is the sum of the previous 2 terms. For example, if the first 2 terms of an FT sequence are 8 and 7, the sequence will begin as blah, 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 blah. You can see right here, 8, 7, 15, 22, 37. And for some positive integer m, there are exactly 2,415 FT sequences, where the first 2 terms are each less than 2m. And the number of odd value terms is more than twice the number of even value terms. What's the value of m? So this is the last problem on the Gauss contest. Let's try to do it together. I think we only have time for this. Okay. So I want to find the value of m. But first, let's look at what kind of FT sequences we can have, right? So we want an FT sequence where the number of odd terms are more than 2 times the number of even terms. So let's say we have odd number and even number. Well, so let's start with 2 numbers for the sequence. Let's say you start with an odd number and an even number. Now, if we keep adding them, so let's add the odd number of even number. That's how we get the FT sequence. So if we add an odd and even number, we get another odd number. Now, if we add an even and an odd number, we still get an odd number. Okay, and now we have odd plus odd, which is even. And now let's continue the sequence. We have odd, odd, even, blah, blah, blah. And now you can see a pattern, right? We have, for every like 2 odds, we get 1 even after that. That's basically the sequence. But we need to make sure that the number of odds exceeds the number of evens times 2. So let's look at number 2020. So 2020 is the number of terms in an FT sequence. And we can see a pattern for like every 3 terms. So let's divide this number by 3 and see what we get. So once you divide that by 3, it's not going to divide evenly. It's 673 with a remainder of 1. And this remainder of 1 is very important because if you keep repeating like a sequence of 3 terms, so if you look at first 3 terms, next 3 terms, and next 3 terms, let me write over here. So that's 3 terms, that's 3 terms, that's 3 terms. This remainder of 1 means that the sequence will end with the first term of the 3 sequence, the 3 term sequence. This remainder of 1 will end with O. Give me a thumbs up if you understand that. This is very important. Okay, that sounds good. So, but now we need to make sure that the number of odd numbers is larger than 2 times the number of even numbers. How do we do that? So remember that for each of these 3 number sequences, we have 2 odds for 1 even, right? And so what this means is that So say we have 2019 terms. So that is divisible by 3 then. If we have 2019 terms, the number of odds will always be equal to 2 times the number of evens. So because we have, this is divisible by 3, right? This is divisible by 3. So that means these 3-term sequences will fit perfectly. And so that means the number of odds, so there's 2 odds for 1 even. So that means the number of odds will always be 2 times the number of evens for 2019 terms. And so if we want an extra term for 2020, we must make sure that the first term has to be odd. If we want to exceed the 2 times number of evens, we must make sure that the 2020th term or the first term is odd. And this won't matter at all. This can be odd or even. So now we have 2 cases. We have the first 2 numbers are both odd. The second case, we only have 2 cases. And the second case is that the first number is odd and the second number is even. Okay. So give me thumbs up if you understand that. These 2 cases are important. So the second number in the term doesn't really matter. All we need to make sure is that the first number in the term is odd. Okay. Now let's try to find m, right? That's what we're trying to solve. And so we're trying to make an equation now. So we're trying to make something equal to 2,415. So number of FT sequences is equal to this number. Okay. First thing you need to do is like find a number of we need to make an equation for like the number of odd terms between 1 and m, including both of them. And so what this means, 2m, right? Okay. So we need to make sure that number of odd terms between 1 and 2m is equal. We need to find a formula for that. The obvious thing we can do is just divide by 2, right? So that gives us m. Here, let me think about it for a sec. Okay. So 2m minus 1. Oh no, okay, sorry, I got it now. Okay. Okay, so never mind. Let's pretend that we have the first term, and now we want to find the number of terms, number of FT sequences between like that first term and then 2m, the 2m. So the number right before 2m would be 2m minus 1. So this would have to be the second term. This would be the number of sequences where the first term is equal to 1. Hopefully you guys can see why. If you count 1 from all the way to m minus 1, that's obviously 2m minus 1. Now, let's set the first term to 3. So we go from 1 to 3, and the number of terms should be 2 less than this. So now we have 2m minus 3. If we continue that, say the first term was 5, we get 2m minus 5. Actually, just wait. Oh, wait. Okay, never mind. No, they're actually all equal to 2m minus 1. I'm sorry about that. Just so this is for the first, when the first term is equal to 1. This is for the first term is equal to 3. This is for the first term is equal to 5, and blah, 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 blah. They will all equal to m minus 1. But then how many of those are there? We actually have, so we want to find number of 2m minus 1s between 1 and 2m. And so let's simplify this. We'll make it into a product. So minus 1, and there's a number of terms between that. There are actually m of those 2m minus 1s if you count them, hopefully. Yeah, so there are m of these 2m minus 1. So there are m odd number terms between 1 and 2m. Hopefully you guys can see that, see why it is. There's m of them. So now if we expand this, now we can solve for m now. We have this, where we have one variable, and then in the equation, we can solve for m. So now let's expand this. So we have 2m squared minus m is equal to 2415. Now this is a quadratic equation. So now let's move the 2415 to the left side. That's how we solve quadratic equations, right? Oops. Did not mean to do that. Minus m plus, sorry, minus 2415 is equal to 0. Now this is actually factorable. I'll just show you what the factored form looks like. See, hopefully I'm right. I did this beforehand. Now I'm kind of forgetting about it. Okay, good. So this is what the factored form should look like. We can actually just expand out, just double check with this. So 2m times m, that's 2m squared. We have negative 35 times 2m, which is negative 70m, minus 70m, plus 69m, which is negative m. So that's perfect with this. And I did 69 times negative 35. I did that beforehand. It is equal to 2,415. So once you, so now we can just solve for m right here. We can have m is equal to negative 69 divided by 2. Or we can have it equal to 35. But obviously m has to be positive, right? M must be a positive number. So it means our final answer is m is equal to 35. Give me thumbs up if you understand all of this. I know it's a bit long, a bit confusing, but it's a challenging problem, but it's very fun. So hopefully you guys understand it. And I know we didn't finish all of the questions for the 2020 Gauss contest today, but I will share this slideshow with you guys after this meeting. So if you guys want to look at the questions once again, I will share the slideshow. So this is what question 24 looked like. We didn't do this one. We didn't do question 23. It's a geometry problem. And question 21, it's a ratio problem. You can just use simple algebra to solve this. Okay, so I will end the meeting here then. So thanks once again for your participation, and I will see you guys next week. And then I'll post the slideshow later today. So see you guys next time.
Bye.
Goodbye.
Bye.